So this one was a concept assessment pop quiz related to topic atomic physics. In the first question, the scattering of alpha particle by a thin metal foil support a neutral model of an atom. Like when the alpha particles scatter through this metal, it shows that there's a nuclear atom, means like there's a nucleus is present in the center. So why are alpha particles used rather than neutron? Like why we did not use neutron, why we use alpha particle? So basically, we have to distinguish between an alpha particle and a neutron. So what is alpha particle? Alpha particle is two proton and two neutron, and this is only neutron. An alpha particle is charged like plus two relative charge, and neutron does not have any charge. Because they always travel because they always travel more slowly. That is not an answer or a reason for that. Because they are heavier, even though alpha particles are heavier, but that is again not the reason. Because they have a large diameter, not the reason. Because they have a positive charge. So what is the advantage of having a positive charge? Because what will happen if this is an atom and the center dot is representing a nucleus? Because alpha particles are positively charged or charged, we know like charges repel each other. So these alpha particle will deviate. So using the alpha particle or a charged particle, we can identify that there is a charge present in the nucleus. Otherwise, what might happen if we were using a neutron? Neutron is neutral, so without any like neutron will not experience any repulsion from the nucleus as it does not have any charge, so it won't change the direction. So main purpose of using an alpha particle compared to that of neutron, as alpha particles are charged, so we can identify that is there a charge in the nucleus, because if the particle deflect, it means the nucleus is having a charge. If particle does not deviate or deflect, it means nucleus is uncharged. So we have to use the charged particle here. That's why alpha particles were used. Is it clear, this one? In question 2, iron nuclide is represented by a symbol. You can see Fe56 and 26. Which statement about the nucleus of this iron nuclide is correct? So the nucleon number A is equals to 56 and the proton number is equals to 26. If you want to find number of neutron, that is A minus Z, which is 56 minus 26, that's equal to 30. If you want to find number of the proton, that is same as Z, which is equals to 26. And the electron, it's a neutral atom, so it will have 26 electrons. Now we have to check which statement. The nucleus contains 56 neutron. No, nucleus contains 30 neutron and nucleon number is 56, but not the neutron number. The nucleon number is 30. That's also wrong. Nucleon number is 56 because this number is a nucleon number. And the proton number is 26. So there are 26 proton. That's why D is the right answer. In question 3, when a beam of alpha particle is incident on a thin metal foil, most of them follow a path represented by X, and a small number of particles are following the path Y. What X shows, because most of the major portion of atom is empty, that's why most of the alpha particles are able to pass through. So X shows as most of them are, so major portion of an atom is empty. And Y shows that there is some, because like the repulsion is there, atom contains something that repel alpha particle, or there is also a mass present in the nucleus that is also causing it to deviate. That's why. So A is the right answer. When they change the direction, it shows that there is a mass and charge. And if it does not change the direction, it shows that major portion of an atom is empty. Then in question 4, the isotope of americium is shown here. complete a nuclide equation for this. So whenever there's an alpha emission, the nucleon number decreases by 4. So this will become 237. And the proton number decreases by 2. So this will be 93. And this will be the symbol for alpha particles. Then describe how americium ionizes the air. It's a 3-mark question. You have to just explain the ionization. So what will happen? As americium is emitting out alpha particles, these alpha particles have greater mass and charge, so they can remove the electron from the air molecule. So how the 3 marks are distributed? 1 mark is for representing that americium is emitting out or alpha. The second mark is there, alpha is having greater mass and charge. And the third, it will remove the electron from an atom or a molecule, you can also say. So this is how the marks are distributed. So what actually happened? Like this radioactive source is there. This radioactive source will emit out alpha. Alpha means like 2 protons and 2 neutrons. And this alpha particle will interact with an atom or a molecule of air. And when it interacts with a molecule of air, it will knock out this electron. As a result, it will produce a positive ion and electron. So americium is emitting out alpha. That alpha is having a greater mass and charge. When it interacts with a molecule, it will knock out the electron from a molecule, which result in ionizing the air. Is it clear? Part B1.
Yes, sir. Clear.
Then suggest and explain 2 reasons why smoke detector uses an isotope that emit alpha particle rather than a gamma emission. First thing, we want it to be ionized, like we want the air to be ionized. So that is a working principle. If air is not ionized, it won't work. So one of the reason here, because alpha particle is having a greater ionization, so it will ionize the air easily. Because ionization of air is responsible for its working of the smoke detector. How it will work? The working of a smoke detector, what actually happen, like example, in case of a fire, the smoke part, like if there is no fire, the alpha particles which are emitted out from the americium will cause an ionization, like produces charges, and these charges move toward their respective electrodes, like positive and negative charges which are produced, they will move toward their respective electrodes and the circuit will work. But in case of a fire, what will happen? It will produce smoke particles, and these smoke particles stop the alpha particle from americium. As a result, what will happen? The air cannot be ionized here. If the air cannot be ionized, the smoke detector, like what actually happened, the charges are not able to pass through as the air is not ionized. As a result, the alarm will ring. So 2 reasons why we are using alpha particle. Number 1, alpha particle is having a greater ionization, so it can ionize the air. And the second thing is it is having a small range, so it won't be harmful, because these radioactive radiation can cause cancer. So alpha particle is having a shortest range. So even a person is there in the room, that these radiations cannot reach a person. The circle in the diagram is representing a radioactive source. This is a symbol for radioactive source, which is emitting out alpha particles, americium. And that causes ionization, and that ionization produces charge air, which the movement of the charges. So smoke detector is there, alarm will not ring. Once in case of a fire, the smoke will rise with the smoke particles will rise with the airflow. As a result, what will happen? The smoke particle will block the alpha radiation from the source, so the air won't be ionized and the detector alarm will ring. Is it clear, this one? Why smoke detectors are using alpha particle rather than gamma?